In this lesson, we will examine the properties of two types of triangles, and we will study two formulas for finding the area of a triangle. The first triangle we will examine is an isosceles triangle, which has two equal angles and two equal sides. Here's an example of an isosceles triangle. Notice that this triangle complies with our rule that says the angles of a triangle correspond to their opposite sides. So in this example, we have two equal sides, and the two angles opposite these sides are also equal. Now, since it's important to deduce which angles or which sides are equal in an isosceles triangle, let's practice this. This isosceles triangle has two equal sides, so which two angles must be equal? Well, the two angles that are opposite the two equal sides must be equal, so we will denote this as follows. What about this isosceles triangle? Here we are told which two angles are equal, and we must determine which two sides are equal. Well, the two sides that are opposite the two equal angles must be equal, so we will denote this as follows. Now, one of the nice properties of isosceles triangles is that once you know one angle, you can always find the two remaining angles. Take this example. If we know one angle, what are the two remaining angles? Well, the two angles opposite the two equal sides must be equal, so this other angle must be 38 degrees. Now that we know two angles in this triangle, we can use the fact that all three angles must add to 180 degrees to determine that this last angle is 104 degrees. Let's try one more. What are the two remaining angles here? Well, the two angles opposite the two equal sides must be equal, so we will call both angles x for the moment. Since all three angles in this triangle must add to 180 degrees, we can write the equation x plus 40 equals 180. To solve this equation for x, we will simplify the left-hand side, then subtract 40 from both sides, and then divide both sides by 2 to see that x is equal to 70. So the two other angles in this triangle are both equal to 70 degrees. Okay, now let's examine the equilateral triangle. These are triangles with three equal sides and three equal angles. Since the three angles in any triangle always add to 180 degrees, the three angles here are all 60 degrees. Now we will come back to equilateral triangles later in this lesson, but first I want to discuss how to find the area of a triangle. Now the area of any two-dimensional shape refers to the amount of space inside that shape. Area is measured in square units, such as square feet, square centimeters, and square meters. Please note that on the GRE, the square units are sometimes implied. So, for example, a question might state that a certain rectangle has area 10, which we can assume to mean 10 square units of some kind. Now, to find the area of a triangle, we must multiply the triangle's base by its height, and then divide by 2. Another way to write this is the area is equal to 1/2 times the base times the height. Now both formulas will yield the same values, but I'm going to use this one for the lesson. Okay, before we apply this formula, please note that the height of a triangle can also be referred to as the altitude of a triangle, so both terms can be used interchangeably. Alright, now let's find the area of the hypothetical triangle shown here. First, we must decide which side will be the base. Let's choose side BC to be the base. So we'll show that this is the base by adding an imaginary ground. Later in this lesson, you will see why I did this. So if side BC is the base, then we already know that the length of the triangle's base is 10. But what about the height? Well, the height of a triangle is the distance from the vertex opposite the base down to the base such that this line is perpendicular to the base. Now let's say that the height of this triangle is 3. If that's the case, we can find the area of this triangle. This will be equal to the base, which is 10, times the height, which is 3, divided by 2. This evaluates to be 15, so the area of this triangle is 15 square units. Now please keep in mind that the base can be any of the three sides of this triangle. There is no rule that says the base must be the side that is horizontal. So, for example, in this triangle, we could make side AB the base. Now, to make it easier to see what happens when we make side AB the base, let's take our triangle and spin it around like so. Now, as I said, the base need not be horizontal. This just makes it easier to view. Now, if side AB is going to be the base, we will add some imaginary ground here. Once again, we will apply the area formula. Now, we can see that the base here is 4, but we still don't know the height of the triangle. To find the height, we will begin at the vertex opposite the base and add a perpendicular line down to the base, which we have extended by adding some imaginary ground. Let's say that this height is 7.5. So to find the area of the triangle, we will multiply the base 4 by the height 7.5 and divide by 2 to get an area of 15. Please note that we have now calculated the area using two different bases, and both times we got an area of 15. Now, of course, this should not be a surprise, since we were finding the area of the same triangle in both instances. Okay, so that's how you find the area of a triangle. Now, we can use this same formula to find the area of an equilateral triangle. However, it will take long to do so if we are not given the triangle's height. In these situations, you can use this handy formula that applies only to equilateral triangles. This formula tells us that the area of an equilateral triangle is equal to √3 times the length of one side squared, all divided by 4. So, for example, let's say that each side of this triangle has length 6. To find the area, then, we will plug 6 into the formula. When we simplify 6 squared, we get 36. And at this point, we can take 36 over 4 and simplify it as 9. So the area of this equilateral triangle is equal to 9√3. Now, before we end this session, I want to examine one last feature of isosceles triangles and equilateral triangles. First, the isosceles triangle. If we begin where the two equal sides intersect and draw a perpendicular line to the opposite side, then the perpendicular line will split the opposite side into two equal lengths. If we do the same thing with an equilateral triangle, the perpendicular line will split the opposite side into two equal lengths as well. Since these two perpendicular lines are the altitudes of the two triangles, we can say that the altitudes of isosceles triangles and equilateral triangles always bisect the base. Okay, to summarize. In this lesson, we learned that an isosceles triangle has two equal sides and two equal angles. An equilateral triangle has three equal sides and three equal angles. We have a formula that can be used to find the area of any triangle, and we have a special formula that can be used to find the area of an equilateral triangle. Finally, the altitudes of isosceles triangles and equilateral triangles always bisect the base.